Okay, this is one of my favorite pictures of my grandfather. It's back around 1920, I think. But I'll get into what I'm talking about. 1921 was a momentous year for amateur radio. Two attempts were made at crossing the Atlantic via short waves. The first, sponsored by Everyday Engineering magazine, was taken on by the American Radio Relay League when the aforementioned magazine was forced to suspend publication. These tests failed. During the ARRL's first convention in late August, early September of 1921 in Chicago, a second set of tests was proposed by Fred Schnell, the ARRL traffic manager. He also proposed that the ARRL allocate funds to send an American hard-boiled owl to England in order to augment the European amateurs, as they may not have been sufficiently hard-boiled. The ARRL Board of Directors agreed to both proposals and to the selection of the, quote, best practical receiving man in the country, so that we would never feel there was a better man we might have sent, end quote. It was agreed that my grandfather, Paul Foreman Godley, was the best choice. When asked, Paul Godley accepted the assignment. The October 1921 issue of QST magazine devoted a page to describe the achievements as of that time of the man they were sending overseas to represent the American hams. As a kid, I knew that my grandfather was a radio pioneer, but did not know the part he had played in early radio development until after his death in 1973. At that time, my mother gave me a box of his old photos and a copy of the story of the first shortwave transatlantic message, which is the shot you see right now, published by the Radio Club of America in the fall of 1950. This was a fascinating read that provided me some insight into the world of early radio and a small bit of my grandfather's role in its history. Much more would surface during the 95th anniversary following the 1921 tests. In 2016, I helped my cousins clean out the house in Great Notch, New Jersey, that my grandfather had occupied for the last few decades of his life. This house had originally been the offices of the Paul F. Godley Company, radio consulting engineers. My grandfather lived on the upper floors from the late 1950s until his death. The company offices occupied the basement until a few years following his death. A great many artifacts, including the original 1921 logbooks from the transatlantic tests, other important documents, awards, components, newspaper clippings, test equipment, and even a barrage balloon used during antenna testing were discovered during this cleanout. The old radios test sets used by the Godley Company in the 1930s and 40s were subsequently donated to the ARRL laboratory in Newington, Connecticut. These are a few of them, just a few. The most interesting find was the 81-page transcript of a 1951 interview of my grandfather by the Columbia University Oral History Library, which at the time was doing a series on radio pioneers. The interview transcript, unfortunately, ends in 1914, after my grandfather's meeting with Edwin Howard Armstrong. The existence of this transcript was unknown to the current organization responsible for such items within Columbia University until I brought it to their attention in my search for more of the interview. An audio tape of part of the interview was discovered in the Columbia University archives and was digitized at my request. I will touch later on a few of his experiences as revealed both during the interview and in some of the other documents found. Paul Foreman Godley was born September 25th, 1889, in a sod house in Garden City, Kansas. He had a brother 12 years older and never knew an older sister that died before he was born. His father was an ordained minister in the Union Christian Church and was responsible for raising funds for denominational educational institutions as guest preacher at various churches. Accordingly, the Godley family moved around a great deal when he was a boy. When Paul was 4, and it was time for his older brother to go to college, the family settled in La Grande, Iowa, where there was a college run by the Union Christian Church. The Godley family stayed in La Grande until Paul was around 7 or 8 years old, while his brother attended college there. In La Grande, the Godley dwelling was along US Route 30, one of the main east-west routes across the country, and along which the first telegraph and telephone lines that crossed the state of Iowa were strung. The installation of these lines excited Paul's curiosity. He pestered his brother and father to explain the laws of electromagnetism to him. They built a tin can telephone for him between the house and an outbuilding, and thus began his firsthand experience with sound and how it travels. Shortly thereafter, his brother and a friend built a telegraph line between their houses, which were roughly a quarter mile apart. Paul was forbidden to use the telegraph when not in the presence of his brother. However, he admits that he sometimes fooled with it, but never got caught. A few years later, his brother gave him a pair of telegraph keys and sounders for Christmas. Paul then, about 6 or 7 years old, set up a telegraph line with a friend of his and became an expert telegrapher, though he did not realize that until a number of years later. The first successful transatlantic wireless message was transmission of the letter S in Morse code by Guglielmo Marconi on December 12, 1901. This was one way westbound from his high power station in Poldhu, Cornwall, England, to Signal Hill, St. John's, Newfoundland, Canada, a distance of 2,200 miles. And I just recently learned from a book named Thunderstruck, which is very well researched, that message, that letter S, was received on an aerial that was held aloft by a kite in St. Signal Hill, Newfoundland, believe it or not. Anyway, it was not until December 17th of the following year that a successful message was passed in the eastbound direction from Marconi's Glace Bay, Nova Scotia, Canada station. Marconi's transmitters were so-called spark stations, which used RLC networks to produce damped sinusoidal carrier signals when excited by a train of high voltage sparks during activation of the telegraph key. The frequency of the sparks was determined by the speed of the rotary spark gap typically used and provided the audible signal that would be heard by the receiver once the carrier frequency was filtered out. This technology, though effective, was quite crude by today's standards and would later prove quite inefficient in its use of the radio spectrum. My grandfather had turned 12 earlier in the year of Marconi's westbound success and marveled at the possibility of communicating over such distances without the need for wires. He was also surprised at the fact that Marconi was only 27 years old, at the time of his success. Paul had already decided on a career in communications, and Marconi's feat piqued his interest in telegraphy without wires. That year had a profound effect on Paul, as his mother had also passed away. His father continued to work as an itinerant money raiser for the church, so Paul was sent to live with various relatives. Consequently, my grandfather felt that the church had stolen his father from him. Paul started his preparatory year in college in the fall of 1904, the year he turned 15. Though his father and brother covered the cost of his first year of college, it was understood that Paul would be responsible for any subsequent years of his education. In the 1907 yearbook, Paul was one of 5 students in the Defiance College class of 1909 in Defiance, Ohio. Excuse me. Each of the 5 students was profiled in a good-natured way. Paul's hobby was reported to be electricity, and it was said to be dangerous to shake hands with Paul Godley unless one was insulated against 2,000 volts of electricity. It was also reported that he was then hard at work perfecting his homegrown wireless telegraph apparatus. As he had flaming red hair, they called him Red. Paul felt that the Defiance College offered only a limited opportunity to pursue his interest in science. The principal advantage of Defiance College was that the tuition and living costs were low, as it was a denominational school connected with the church with which his father was associated. The physics laboratory facilities had only the basics, but while there, Paul installed motor and generator equipment that was donated to the laboratory by a local electrical contractor. This was because the physics professor had little practical experience in doing so, recognized Paul's capabilities, and appointed him to do the work. The summer following his first year of college, Paul was en route to his summer job as an electrician's helper in Kokomo, Indiana, when he had to change trains and wait several hours at a station along the way. Hearing the telegraph through the ticket window, Paul decided to practice his telegraphy skills by copying the messages onto the backs of handbills. At some point, the agent came out and caught him, asking to see what he had copied. To the agent's amazement, it was a practically perfect copy. Paul was then told that the railroad was badly in need of telegraphers and was asked if he was hunting a job. He told the agent that he already had a summer job, and the agent asked how much that job paid. When he was told, the agent responded that the railroad would likely pay double that if Paul would contact the chief dispatcher on the wire and talk with them about a position. After, quote, talking, the chief asked Paul to copy a message intended for the conductor of the next westbound passenger train, authorizing him to pass Paul to Frankfort, Indiana, for an interview with the superintendent of the telegraph on the Toledo, St. Louis, and Western, otherwise known as the Cloverleaf Railway. This resulted in his first professional experience as a telegrapher at the age of 15, working 12 hours a day, 7 days a week. Paul worked as a telegrapher for the Pennsylvania Railroad, Western Union, and Postal Telegraph companies in subsequent summers. Paul's favorite job was working as a quote, bonus telegrapher on a high-speed circuit. As there were limited facilities between cities and high traffic demands, The bonus operators would be required to send and/or receive a given number of messages an hour, 60, for example. A bonus of 1 cent or 1.5 cents would be paid for every message handled beyond that threshold. As summer help, the best he could do was to relieve the regular bonus men while they went on vacation. Sometimes he would find a second job relieving a night wire chief or multiplex chief during their vacations, working up to 16 hours a day. His goal was to earn enough money every summer to pay off his debts, buy a new suit of clothes, pay the entrance fees in the fall, buy the necessary books, and get ready to start accumulating debt again in the year ahead. He felt he was lucky to be able to get the credit, and fortunately, he was always able to meet his obligations. During his time attending Defiance College, he took jobs during the school year as well, including running a laundry route, waiting tables, and contract work, including wiring a new business building in town for which he was paid $120. One of his neighbors in the boarding house was the local long line troubleshooter for the American Telephone and Telegraph Company. As Paul and this man talked quite a lot about electrical things, when this man fell and broke his leg, he recommended to his superiors that Paul would be able to take care of things while he was laid up in the hospital. Though never interviewed for the job, a special arrangement was worked out where they would call Paul out of class if necessary and tell him what needed to be done. Paul would then call the livery stable to hitch up a horse and buggy so that he could go out, find the problem, and fix it. Of course, he had to make up his studies, but it was very good experience. In the spring of 1908, his junior year at Defiance College, Paul heard that the United Wireless Telegraph Company had installed a radio station on the roof of the Congress Hotel in Chicago. He hurried over there to find out more about it. Paul had built a crude but functional spark coil and coherer wireless setup during his time at Defiance, and it appeared he knew more about what was required than the chief operator and the superintendent of the Great Lakes division of the company. Paul was offered a job at once as an operator on one of the ships being equipped with the United Wireless Telegraph Station. Following this, he would take over the job of installing ship and shore stations in the Great Lakes area. He would never actually graduate from college. Paul had read about Lee DeForest's invention of the Audion in 1906, and also of John Ambrose Fleming's invention of the Fleming valve in 1904. The latter was the first practical application of the Edison effect, noticed in the early 1880s by Thomas Edison during the development of the incandescent light bulb. The Fleming valve was the first two-element vacuum tube, a diode. DeForest had augmented this with a third element we now call the grid between the filament or cathode and the plate or anode, thus turning the diode into a triode. Having heard that DeForest had a laboratory at the top of the Majestic Theater in Chicago, Paul went up to meet the man and talk about radio. DeForest indicated that he, DeForest, did not talk to anyone, and to, quote, get the hell out of here fast, end quote, which Paul promptly did. In his remarks at the 50th anniversary dinner of the Radio Club of America in 1959, Paul stated he was bodily thrown out of DeForest's lab. Paul later met two of DeForest's employees that were telegraphers on an excursion steamer equipped with DeForest's apparatus. As a result, Paul came into possession of two of the Audion devices and a rough understanding of the circuit configuration in which they were being used. Paul rigged up one of these tubes in a receiving set and got it operating. In the process, he found it was a very erratic gadget, but when it was operating, the received sensitivity was phenomenal. After a few hours of experimentation with it, the filament burned out. While installing a station on a Great Lakes steamer, Paul met George M. Dodge, the son of the founder of the Dodge Institute of Telegraphy in Valparaiso, Indiana, and who was operating the school at that time. Dodge spent an hour or more talking with Paul about wireless. Later that year, 1909, while Paul was in Grand Rapids getting a United Wireless station functioning properly, he received a letter from Dodge suggesting that Paul might come down to Valparaiso and teach courses in wireless telegraphy, which the Dodge Institute did not then provide. He was made a very attractive offer of employment. Paul accepted, and at the age of 20, wrote out his own texts for the lectures, eventually to be put into textbooks. He then taught the courses in wireless that began in December 1909. His first class included some 18 students. They were taught the basic physics of electromagnetism, transmission of sound, and architecture and operation of wireless equipment. As a bonus, each student was provided with their own little wireless station, which they could use to communicate with each other around the small town of Valparaiso, practicing their telegraphy. These devices were battery-driven buzzers with a single-side tuner and crystal detector that Paul had designed and built for them. After 8 months, including the required telegraphy courses, these fellows were in high demand by the wireless companies, as this education was not available anywhere else. Paul entered the University of Illinois Electrical Engineering School for the 1910-1911 school year to learn more about radio. However, Paul claimed this year was basically wasted, as he didn't learn much that he did not already know. In addition, the dean, who he had hoped would provide more insight into the physics of wireless technology, maintained that, quote, nothing would ever come of wireless telegraphy, and that he, Paul, had better get into the power game, end quote. In those days, all students at the University of Illinois were required to be involved in military training. Paul did not want to participate and persuaded the battalion commander that it needed a wireless squad and a radio. He built them a radio and trained the squad in its use. In return, Paul did not need to attend military drills, though he still needed to wear the uniform. In early 1913, Paul went to Brazil on a 2-year contract with the government there. The job included putting together the, quote, Amazon to the Andes, end quote, radio network, and an organization that would serve the Madeira Mamor Railroad, the government of Brazil, and provide communication with the neighboring countries of Peru and Bolivia. The railway itself was being built to circumvent the falls along the Madeira River in the heart of Brazil, roughly 1,000 miles up the Amazon, and would serve the productive rubber plantations in that area. This was very valuable experience for Paul, though there was little that he had not already done, except that the power was much greater. The wavelengths of operation were between 4,000 and 8,000 meters, or 75 to 37 kilohertz. And the antennas were high and large. In Manaus, there was a dual 70,000 watt installation that could be configured for a maximum power of 140,000 watts. The other stations were smaller 5 and 10,000 watt setups. While there and wondering about the possibilities of operation On shorter wavelengths, Paul sent a letter to Dr. Alfred Goldsmith at the College of the City of New York, asking whether his new course offerings there would enhance Paul's understanding. Dr. Goldsmith replied, quote, "With your background, the cost in time and money could scarcely be justified," end quote. Paul came back to the New York area in mid to late 1914 with $5,000 in gold, $130,000 today. Actually, it might actually be more today, and used this to set up his laboratory in Leonia, New Jersey. Shortly after his return, he met Louis Payson, a clerk in an electrical supply store that handled wireless components. Louis happened to be a member of the Radio Club of America, and after dinner, took Paul to a meeting of the RCA that very evening. Paul was surprised when, after the usual technical presentation, Louis asked him to come up and provide a few remarks about his communication experiences in Brazil. After his remarks, a big, gangling, bald-headed man got up and reported that he had heard the Amazon stations on numerous occasions. This was hard for Paul to believe, but comparing notes with this man after the meeting was over, it seemed Edwin Howard Armstrong had a detector that was able to receive the stations along the Amazon. Paul asked to see his rig. Armstrong indicated that he had not yet fully secured the patent situation on his detector, but he would be glad to show it to Paul, which he did a few days later. When asked whether he had been able to get it to work on short waves, Armstrong replied that he had not. These two would go on to become good friends, and Armstrong would utilize Paul in several of his later demonstrations and ventures, including the demonstration of FM, or frequency modulation of radio waves, in November 1935, Armstrong's third major invention. In the ensuing year, Paul set up the experimental radio station 2ZE, started researching the performance, characteristics, and applications of DeForest Audion for operation on the shortwaves in his Leonia laboratory. He took the Armstrong circuit configurations, then considered impractical for shortwave applications, and designed the first shortwave regenerative receiver for amateurs, the Paragon RA6. His station 2ZE captured all distance records of the time, handling daytime traffic consistently from Albany to Leonia to Baltimore and Philadelphia. Paul bought into the Adams Morgan Company, a radio component supplier, as a one-third partner in late 1915 in order to commercialize his Paragon series of receiver designs. The RA6 was ready in October 1916 at a cost of $35, about $860 today. And it was quickly found in many of the better ham stations. Also in 1916, he, according to Chris Codella in the Ham Radio History blog, that's w2pa.net, quote, wrote the first in-depth article about circuit design with the Audion, being one of the first to explore its use on short wavelengths. Filling nearly 8 pages, Godley methodically presented receiving circuits of increasing complexity, ranging from the one-tube simple regenerative detector up to a 4-tube receiver that employed 3 steps of audio amplification and interstage transformers, ignoring with gusto Cole's admonition against using the Audion for anything other than detection, end quote. At the time, A.B. Cole was the sales engineer for DeForest Company and had produced several previous articles on the use of the Audion. Paul presented the paper entitled Applications of the Audion at the June 1916 RCA meeting, and it was published in the August issue of QST magazine that year. And I've skipped a few slides, it seems. And there's the article. There were several attempts to legislate radio amateurs off the air in the early years of radio, as interference was a big problem for reception of any given station during the spark era. As of sometime in 1912, the amateurs were limited to wavelengths of less than 200 meters, or 1.5 megahertz, and primary power levels less than a kilowatt. These short wavelengths were considered to be commercially useless, and all the commercial and military stations were using much longer wavelengths. The Radio Club of America, effectively born in 1909 in the New York City area, had successfully opposed elimination of amateurs from the radio spectrum in 1910. However, it was unable to alter the Radio Act of 1912. The American Radio Relay League, formed in 1914 in Hartford, Connecticut, was based on Hiram Percy Maxim's premise that since long-distance communication on the short wavelengths did not appear likely, a relay network would allow amateurs to effectively extend the range of their stations. It started recruiting amateur radio operators, and by August of that year, over 200 stations capable of relay work were signed up. The first call book was published in October 1914. ARRL members achieved the first transcontinental relay from Rock Island, Illinois, to each coast in less than an hour in February 1916. The first coast-to-coast and back relay was achieved in an hour and 20 minutes on February 6, 1917. Paul became quite active in both of these organizations in 1914 and served in various roles in each, including president of the Radio Club of America in 1939. Paul conceived, outlined, and promoted the idea for an ARRL Radio Amateurs Handbook in 1918 to 1919. All radio amateurs likely have a recent copy. He also promoted the idea that the ARRL laboratory be staffed with paid personnel as it is now. When the US, in April of 1917, following its entrance into World War I, the US government banned all radio amateur activities. Publication of QST magazine ceased after the September issue that year and did not resume until July 1919. Many amateurs, encouraged by the ARRL, had entered the service and provided much needed radio and telegraphy expertise to the war effort. Short of radio communications equipment, the US military offered to buy equipment from amateurs at fair value. After the war, many amateurs upgraded their stations with new receiving equipment containing more sensitive detectors based on the Audion. In addition, using the Audion as an oscillator, many were switching to CW or continuous wave instead of spark transmitters. As a result, longer distances were being achieved even at the low power outputs required to comply with the 1912 Radio Act. When the US entered World War I, my grandfather accepted a commission in the US Army Signal Corps, as did Armstrong. However, Paul's commission was annulled by the Secretary of War at the insistence of the Navy. He was instead assigned to take charge of radio receiver design at the American Marconi plant in Aldine, New Jersey. There he developed the Navy's first regenerative receiver collaborated on development of the Navy's first aircraft radio telephone telegraph transmitter, and designed for the Signal Corps a 6-volt battery-driven 50-watt transmitter receiver for use in the trenches. The regenerative receiver was the only American-built vacuum tube equipment to see service on the Western Front before the armistice, and was used for intercepting enemy radio transmissions. While at American Marconi, he was also involved in many other developments, too numerous to mention. A cryptic letter from Armstrong, serving in France at the time, got Paul thinking about what eventually became the superheterodyne, Armstrong's second big breakthrough. Once it hit Paul, he designed, built, and got operational the first superheterodyne receiver before Armstrong returned from Europe. And here's the, his the Paragon receiver. I have one of these actually, and this was ready in the 1921 era. Paragon Paul, as he was called, sailed for England on the Aquitania on November 15th, 1921, to prepare for the transatlantic tests. He took receiving equipment of his own design, a Paragon regenerative receiver with a DA2 detector amplifier and a superheterodyne receiver which had a total of 10 tubes, including the external beat oscillator. At a Bon Voyage dinner with the ARRL and RCA friends, and that's the Radio Club of America friends, he voiced his wish that someone build a station that could get across. E.H. Armstrong said, quote, "I'll stake my scientific reputation on Paul Godley." And so many others chimed in that another said, quote, "Paul, it looks like a cinch." Paul was given a sealed packet to be presented to the editor of the Wireless World magazine in London, Philip Corsi, who would be overseeing the tests in England. This packet included the secret codes and final transmission schedules of the American stations that had qualified for time slots during the tests. Only 2 copies existed. The other was locked in the safe at ARRL headquarters. On the Atlantic crossing, Paul met Harold Beveridge, an RCA, Radio Corporation of America antenna designer and hard-boiled ham. They spent much time in discussion of a new type of antenna to reduce static, which Paul eventually erected for the tests. In London, he made an appearance at a meeting of the Radio Society of Great Britain. There he met Guglielmo Marconi, who not only wished him well in the tests, but also stated, quote, "I too am but an amateur," end quote. At the time, success was not assured. And the London hat maker bet a new spring derby that Godley would hear no American amateur signals. Discovering unacceptably high harmonics and static in the originally planned London location, Paul selected a receiving station on the Scottish coast at Ardrisson near Glasgow and made the decision to move his equipment there to set up for the tests. Paul was resolved to get signals or bust. The British, excuse me again. The British radio folks were very accommodating, whisking his 285 pounds of equipment through customs, extending the special operating permit from the original London location to the final site selected in Scotland and making the necessary travel arrangements for Paul and his equipment. However, when it came to the actual tests, Paul had the same status as the British amateurs. The free-for-all schedule was public information, but the time slots for specific American stations were not. All radio receptions, whether by Paul or any British amateurs, were to be reported to Mr. Corsi for verification. Every day of the test, Mr. Corsi would then wire the results to the ARRL at 7 a.m. Greenwich Mean Time the next morning via MUU, the British Marconi station at Carnarvon, operating on 14,200 meters, 21 kilohertz. Once in Ardrossan, the receiving site selected was in an open field without any buildings. A tent was erected as time was too short to erect anything more comfortable to house the station. The only light available was a lantern. The only heat, an oil stove. The weather was reported to be the worst imaginable: cold, rainy, and windy, resulting from a passing cyclone. Mr. Pearson from the Marconi Company at Glasgow stood constant watch along with my grandfather and, as checking operator, verified the reception of every signal. On December 7th, the first day of the tests, the tent was erected, the antenna finished, the equipment and batteries unpacked and found to have survived their long journey, and all was ready to receive signals at 11:30 p.m. that night. In the night, the antenna came down due to the wind and had to be repaired, resulting in a half-hour gap in reception. No signals were received that or the following night. The night of December 9 to 10, after listening for the free-for-all sparks, Paul moved over to CW on 230 to 235 meters and found one BCG steady and reliable. One BCG is calling PF test and signing. One BCG signs off around 2 a.m. Unknown to my grandfather at the time, a few folks at the Bon Voyage dinner had taken his wish seriously and built a station that did get across, though it took all of the roughly 3 weeks since Paul had sailed to England to complete construction of the aerial, ground plane, design, installation, and testing of the transmitter receivers and required generator set. At that point, my grandfather knew this was a, quote, history-making set of tests that American amateur radio has the world by the ears, end quote. He also indicated that he would have given a year of his life for a, quote, 1 kilowatt tube transmitter, a nice upstanding aerial, and a British Post Office license to operate it on 200 meters. To be forced to listen to a Yankee ham and only listen is a hard blow, end quote. On the night of December 10 to 11, they got set up at 12:50 a.m. One BCG comes in steady again, sending MGES over and over. At around 3:30 a.m., Paul recognizes a new operator and suspects it is John Greenan, who sends PF in American Morse and 2ZE twice. A number of other American stations were received as well, some just working local contacts, not part of the test at all. At least 2 of these were known by Paul to have output power less than 30 watts. On the night of December 11th to 12th, exactly 20 years to the day after Marconi's record-breaking achievement, they are ready to receive messages at 1 a.m. on 600 meters. After 25 minutes, they go to the short waves. An American Spark Station 1BDT comes in strong, sending test and transatlantic tests. One BCG says bye 1 hour at 1:50 a.m. and is back at 2:52 a.m. with the following history-making message, which takes roughly 8 minutes to transmit in code. And it is, number 1 from 1 BCG, words 12, New York, date December 11th, 1921, to Paul Godley, Ardrossan, Scotland. Hearty congratulations, Berghard, Inman, Greenan, Armstrong, Amy, Cronkite. The test continued for several more days, but little was received. Because of the change in location to Ardrossan, the station was closed down for the last time on the morning of December 16th, a day earlier than originally planned. Paul had been scheduled to spend Christmas at home with his family, including my then 1-year-old mother and my Uncle Paul Jr., an infant. Even so, he did not get back in the States until the 27th. My grandfather later reported that the Paragon superheterodyne and regenerative receivers pulled in signals in a manner which astounded everyone, including Pearson. At the time, the British amateurs did not have regenerative receivers, and their only choices of wavelengths were 1,000 meters or 180 meters, and they generally chose the longer of the two. These are likely some of the reasons they did not receive any signals in the earlier 1921 tests. The success of the second transatlantic shortwave tests and the changes they have wrought on radio design and spectrum allocation are legendary. The opinion that the shortwaves were commercially useless was proved completely wrong. In fact, great distances can be and are being achieved on shorter and shorter wavelengths using CW and newer modulation techniques without requiring such high power levels. Most amateurs switched to CW within a year of the tests, and spark technology was made illegal by 1929, even for the commercial stations. Amateurs had shown the way. The first shortwave, the first successful shortwave tests in the westbound direction followed the year after the eastbound success. At the second annual dinner of the Executive Radio Council in March 1922, my grandfather was asked to provide a few remarks. He closed by briefly relating a conversation he had had with Admiral Sims in Washington a few days before on the similarities of their jobs. Admiral Sims said, quote, "I had a job a short time ago of going across to Europe and ensuring the freedom of the seas. And you are down here trying to ensure the freedom of the air," end quote. He went on to say, quote, "Amateurs won the war we must allow, so let's give the boys their bonus now," end quote. Any radio amateurs involved in DX contests today are keeping alive the tradition of the early ARRL transcontinental and transatlantic tests, whether national or international in nature. Thank you for your attention. And we can open it up if there are any questions. This is that's the last slide there, so.
Bruce, wonderful, wow. I learned a lot, and I'm sure so did everybody else. Let's do some questions around the horn in any order. So just blurt them out. Come off of mute, and we have some expertise here that we can pick up on.